Let's revise intermolecular forces. So the first important concept is electronegativity, which is the ability of an atom to attract electron in a covalent bond towards itself. Here is the trend. Just like the nuclear attraction, it increases across the periodic table and up the group. Remember, the trend is important because you will need to identify which are the bonds that are polar. In fact, the difference in electronegativity results in polar bonds with partial charges. So a polar bond doesn't necessarily mean a polar molecule. Look at these two examples. When the dipoles cancel out because they're in opposite directions, it's a non-polar molecule. So polar, there must be a net presence of dipoles. So symmetric molecules are non-polar. In the next video, we will look at intermolecular forces. So this difference in electronegativity results in the formation of some forces. Dipole-dipole interaction, it's one, also called permanent dipole, which arises due to the difference in electronegativity between atoms. In fact, forms permanent dipole, remember, is only between polar molecules like HCl. The more polar the bond, the stronger the force, and remember, the opposite dipoles of different molecules are attracted. A stronger version of it is a hydrogen bond, which arises due to the difference in electronegativity between atoms. It forms a permanent dipole, so it's the same, but is only between a nitrogen, oxygen, oxygen, hydrogen, fluorine, and hydrogen. Why? Well, because these are the most electronegative atoms. So know this diagram, it's important. You need to be able to represent the hydrogen bond between water molecules or ammonia. Remember, the opposite dipoles of different molecules are attracted. And finally, the one that doesn't depend on dipoles, but it's London dispersion force or induced dipole. It's caused by an uneven distribution of electrons, which means that there is a temporary dipole which induces, look at this diagram, induces the dipole in the adjacent molecule. And here it only depends on the strength of the number of electrons. So dipole-dipole hydrogen bond, London dispersion force, different nature and different strength. In fact, let's look at the effect of intermolecular forces. The stronger the force, the more energy is required to break it. Therefore, the higher the boiling point. In fact, the London dispersion force is generally weaker than dipole, and dipole is weaker than hydrogen because, as we said, hydrogen bond is the same nature as dipole-dipole, but between more electronegative atoms. Therefore, stronger dipoles. And this is exactly how you need to answer in an exam. The stronger the force, so the more energy required to break it. More energy required to break it, higher boiling point. So when you compare the boiling point of molecules, well, we've seen the intermolecular forces and their effects, but this is only for covalent bonds. So covalent molecules, they're intermolecular forces. But what happens if we needed to compare different substances? Well, first we need to identify the bond, if it's ionic, covalent, or metallic. Then we need to identify the structure, giant, if it's of course ionic and metallic, and some of the covalent ones, or molecular. And then we need to compare the strength either of the bonds or the intermolecular forces. So if you're comparing giant structures, of course, these are going to be stronger than molecules because molecules, they're affected by, remember, intermolecular forces. While ionic and metallic, their strength depends on things like charge density, and the effective nuclear charge. So can you think about it for a moment? About what affects the ionic and metallic bond? And here we suggested you think about the definition of them.